Righto lads, so today you're doing moments. I've made a couple of notes. You've got notes on Classroom and you've got some work to do on Classroom as well. So let's start off with the easy part. What is a moment? It's a torque relationship. So a moment is force times distance. Now it is perpendicular distance, not just normal distance, perpendicular distance. So, and we say that if we're in equilibrium, the sum of the moments equals zero. Now, we're not always going to be in equilibrium. We'll talk about equilibriums in a little bit of detail. But here we have a distance and a force. So in this case, our moment is going to be force times distance. Distance is perpendicular to the force, so we're all good. Let's have a look at the first one. Now, when we're looking at this first one, we've got a distance of 2, we've got 60, so it's going to be 60 times 2, which is going to be 120 Newton meters. Now, with moments, again, it's a vector, so we can say that in this case, as we're pulling it down with 60 newtons of force, our moment is going to be positive when it's going clockwise. Right, level 2. We've got two forces here. We've got a kilograms and we've got distance. So, kilograms isn't a force, is it? So, I've got my funky looking diagram. I'm going to change it to a free body diagram. I'm going to call this one 800 newtons, 2 meters, and this side is going to be 2000 newtons at 1 meter. So, what we're going to do here is we're going to have a look, right? So the forces are perpendicular to the distances, that's good. So we're going to have a moment on both sides. So let's do the first side first. So I'm going to do this side first. So my moment equals 2000 times 1. Now, this one is going this way, which is anti-clockwise. We're going to say that moment is positive in the clockwise direction. Let's give this a letter. Let's make it, we'll be really creative. We'll call it A. Then we're going to go the moment B, which is this side. This is going to be B, is going to be 800 times 2. And this one is pushing down this way, which is clockwise, so this one's going to be positive. So the sum of the moments equals, helps if we write out our answer, Mr. Viger, Newton meters. $1,600 take away 2,000, which equals 400 Newton meters anti-clockwise. Which means that this whole thing will rotate in an anti-clockwise direction. So this end will go down, but not by as much as just if that one, if A was there by itself. Die cutters. So this one is an interesting one. We've got this bit here, we've got this bit here, and we want to find the torque. So this is what we call a couple, where we've got two moments acting together. So when I start my free body diagram, I've got this, and it's going down this way, 25 mil, 25 newtons, and I got this one coming out this way, which is going up. It's 25 mil and 25 newtons. This is a really poor choice of numbers, Mr. Viger. So 25 and 25, happy days. So find the torque applied. So the sum of the moments with clockwise being positive. So, start off with the easy part. We're going to work out which way this thing is going. That one is going that way, that one is going that way. They're both going in the same direction. So we're going to say that the moment equals, we've got force times distance. So our force is 25 newtons and our distance is 25. 25 times 25. Got to check it on my calculator. That's a bit sad. I should have known that. Is 625 Newton millimeters. But that does one of them. We've got two, so this is, let's call this one A. We did A first, so we're going to say that the sum of the moments equals 2 moment A. So we're going to say that 625 times 2 is 1250 Newton millimeters. Right, wheel nut. So, average breaker bar is 600 mils. You'll be given that in your question. And we're going to be applying a force. So here we go, we've got our force. It's coming up at 45 degrees. And we're going to say that our force is 85 newtons. So, how do we work out our moment? So, we're assuming that at this stage it's not moving. So, some of the moments clockwise being positive. So, we've got this is 600. We need to work out the perpendicular distance. So, to work out our perpendicular distance, we know that this is 45. So we can say that the perpendicular distance in this case of the force, because the force is going this way, so the perpendicular distance we want to find is this bottom one here, which we're going to call x. So the perpendicular distance, this is just a bit of trig. Now we've got the distance, we can work out the moment. So the moment equals force times distance. Force is 85 newtons times the distance, which is 600 cos 45. And we get our magic answer. Now it's in newtons and millimeters, which is no good to us. So how about we change it? So instead of doing 600, we do 0.6. Newton meters. Right, that'll get us started for today. I'll get you to have a go at some of those questions and we'll go from there. Thanks, boys. Have a good day.